We're going to look at rational exponents today. Rational exponent just means exponents that are fractions. Uh, I don't always necessarily know how to solve something with an exponent, so instead we rewrite it in radical form, so something with a square root symbol, or not necessarily square root specific kind, but a radical symbol, and we manipulate the problems from there. So let's look at just converting between a rational exponent form into radical form. So when you rewrite this, when you see a fraction as an exponent, there's automatically going to be a radical sign. Now, we have three numbers here. We've got that variable x, that's our base, that's what goes inside that radical. Now, our exponent of 1/2, we're going to split it up into two parts. The top of the fraction goes up top, the bottom of the fraction goes down on the bottom. What? Uh, Inside this little valley, this little crack, that's something called the index. The index tells you how many times this number gets multiplied by itself in order to solve. That 2 comes down on the bottom, and that 1 turns out to be an exponent. We're going to throw it up top. We don't necessarily need that 1 right now, but we'll leave it there just for rewriting purposes. Again, let's try it with a number now. So we have a fraction as an exponent. We're going to rewrite it as a radical. The number that goes inside is going to be our base, 25. My index is going to be on the bottom. That's going to be a 2. The numerator is going to be our exponent. That's rewriting in radical form. Now, you got a variable, you got a number. What if I got a variable and a number? So first I need to ask, what does this exponent go to? That exponent only goes to what's directly in front of the exponent, in this case, just the x. So this whole thing is kind of like separated from each other. So I want to rewrite just this portion of it. So we see a fraction exponent, we know we're going to have a radical. Inside that radical gets the x, the index is a 2, that exponent is a 1. Okay, what about that 6 all the way out in front? Well, let's just bring it all the way over, and it stays in front. So you're saying 6 times this whole group. And one last one, then we got 27 to the 2/3 power. So exponent that's a little different, but we treat it the same way. Radical, 27 goes on the inside, then we split this up into two parts. One goes down, one goes up. 3 on the bottom, 2 up top. This one looks a little differently, and now I'm going to explain a little why. So the reason why we don't say these are square roots mean that you have a 2 in this index spot. We could also get a 3, which is called a cube root. To save from the special names, we just say radicals. Now, another important thing to kind of keep in mind, whenever you have an exponent of 1, we don't always necessarily need to show it. You could, that's fine, you can leave it there, but you don't always have to show a 1. Now, like that magic 1 that's there, it could sometimes disappear, we have an index that you don't always have to show, and it's not going to be 1. This time it's going to be 2. If you have a 2, you don't always need to show it. You can leave it there, which is fine, but by default, if you do not see a number there, it's going to be a 2. If you do not see an exponent, it's a 1. All right, now let's take this and put it into practice. I have 16 to the 1/2 power. I don't even know what that's asking. So I'm going to rewrite it, and then I'm going to simplify it. So in order to rewrite it, I know that this means, I know I'm going to have a square root. The number that's going to be on the inside is going to be our base, 16. That 2, it's on the bottom of the fraction. It stays on the bottom in the index. The 1, top of the fraction, goes up top in the air. That's your exponent. Now we can simplify this. We've been dealing with problems just like this, but with less information. We don't need to show that 1. You also don't always need to show that 2. You know what the square root of 16 is. What times itself gives me 16. Well, why do I say what times itself? Because there's an index of 2. What times itself? And we know that's going to be 4. Okay, what if we have the 8 to the 1/3? Well, we have a fraction as an exponent. We know we're going to have a radical. The 8's our base. That's what goes on the inside. Now split this up. 3 is on the bottom. It stays in the bottom. The 1's up top. It stays up top. Now, the same question that I asked up here, what times itself gives me 16, I'm going to kind of change it. I'm going to say, what times itself gives me 8? Well, let's start running down the numbers. 1 times 1 times 1 is going to give me 1. 2 times 2 times 2, 2 and 2 is 4. 4 and 2 gives me 8. What just got repeated? 2 got repeated. So now this says 2, and then I'm going to bring that exponent of 1 over, and we're going to say just 2. All right, keep going. We've got 16 to the square to the 1/4 power. We know we're going to have a radical, 16 inside. Number on the bottom is the bottom of the fraction. Index is 4, exponent's 1. Now we're looking for what times itself times itself times itself gives me 16. Well, if I know 2 times 2 times 2 is 8, what is 8 times 2? Going to give you that 16. So once again, we get that 2 to the first power. Just carry that 1 over and simplify one last step, and it's just plain old 2. We might not always be as lucky having this exponent of 1. Sometimes, or the numerator as 1. Sometimes we're going to have other numbers up there. And we can navigate this process the same way. Most times you're not going to see rewrite and simplify. Your directions are just going to say simplify, but what do we have to do? Rewrite and then simplify. So let's follow that same pattern. We know we're going to have a radical. Inside, 64. For the index, it's on the bottom. We want the bottom of that fraction, the denominator, 3. What number that 2 is up top? It stays up top. Now I'm looking for a number times itself to give me 64. In this case, it's going to be 4. 4 times 4 is 16. 16 times 4 gives me 64. And now I carry that exponent over. I now need to say, what's 64 times 64? I don't know. 64, now we gotta do a little math. 16, 24, 25, 24, 36, and 38, and I hope this is right. Looks it. 4096. All right. It's the same process. The only thing that we added was multiplying by that exponent. So let's do it again. Let's rewrite 36. 36 is under the radical. Our 2 is in the bottom. That's what stays on the bottom. 3 is up top, stays up top. What times itself gives me 36? 6. We have to carry that exponent of 3 over. Now you're asking 6 times 6 times 6. So 6 and 6 is 36. 36 times 6 is going to give us 216. Can we complicate this? Who knows? 256 inside the radical. My index is going to be a 4. Exponent's going to be a 5. Now, what times itself gives me 256? In this case, it's going to be 4 times 4 times 4 times 4. Bring the exponent of 5 over. Now we got to say 4 times 4 times 4 times 4 times 4. Off the top of my head, everyone should know this. 1024. Everyone should know that. Okay, the only difference now, I've got a fraction, I've got parentheses, I've got this exponent. This exponent gets distributed to both numbers. So you're going to have 1, and I'm not going to finish this, but I'll get it started. 64 to the 2/3. All I did was break this up into 2 questions, 2 problems. 64 to the 2/3, we just did that up here. We know it's going to be 4096. And if I were to rewrite all this, just the magic 1, yeah, I guess we are going to finish this one. And that's all. So The only difference that you needed to know here was we distribute that exponent to both numbers, then you simplify both of them. Now, is there an easier way to know all these big numbers? There is. Screenshot that. One more. Screenshot. Take a picture. All of those are all of your possible numbers that you are going to run into. Use them to your advantage. Write them down. Recognize the numbers, but don't memorize. Recognize that they're there so you can go back to your list. And that's simplifying rational exponents.